Today's honors geometry lesson is on proving lines parallel. This can be found in Chapter 2, Section 3 of your textbook. The objectives for today are to learn and apply the postulates and theorems needed to prove lines parallel. In the preceding section, you saw situations in which two lines were given as parallel. You then concluded that certain angles were congruent or supplementary. In this section, the situation is reversed. From two angles being congruent or supplementary, you will conclude that certain lines forming the angles are parallel. The key to doing this is postulate 11. I have also restated postulate 10 from section 2-2 so that we can compare the wording. So postulate 10 states if two parallel lines are cut by a transversal, then corresponding angles are congruent. Postulate 11 states if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Using postulate 11, we're going to go ahead and prove theorem 2-6, which states if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Remember, since we are trying to prove the theorem, we cannot use alternate interior angles as part of our proof and our reason. So we're going to use postulate 11 to prove theorem 2-5. So we are given that transversal T cuts line K and N, and that angle 3 is congruent to angle 6. And we're going to try to prove that line K is parallel to line N. So I'm going to start with my first given statement, which states that transversal T cuts lines K and line N, which is given. I'm also going to conclude from the diagram that angle 2 is congruent to angle 3 based on the theorem vertical angles are congruent. Then I can go back to my second given statement, which says that angle 3 is congruent to angle 6. Since angle 2 is congruent to angle 3 and angle 3 is congruent to angle 6, I can use my transitive property to now say that angle 2 is congruent to angle 6. By looking at the diagram, I've now proven that angle 2 and angle 6 are congruent and are corresponding angles, so now I can state postulate 11 and prove that line K is parallel to line N based on postulate 11, which says if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. We are now going to look at two other theorems that are also deduced from postulate 11, which are the corresponding angles. So theorem 2-6 states if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So if you look at the diagram and you can prove that the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees, or that the measure of angle 4 plus the measure of angle 6 equal 180 degrees, then you can prove that these lines are parallel. Theorem 2-7 states in a plane, two lines perpendicular to the same line are parallel. So if we know that T is perpendicular to K and that T is also perpendicular to L, then we can conclude that lines K and L are parallel. We can use this and prove this based on corresponding angles. We could also prove this on alternate interior angles, and we can also prove this based on same side interior angles. So for tomorrow's class, we are actually going to prove theorems 2-6 and 2-7. Now let's take a look at a couple examples. So based on this diagram, which segments are parallel, and I'm going to ask you to justify your answer. So the first thing we're going to look at is we're going to look at the measure of HIL, which is this angle right here. And if we add 61 degrees and 23 degrees, we can see that the measure of angle HIL is equal to 84 degrees. If we look at measure T and I, which is right here, and we add 62 plus 22, we can also see that the measure of T and I is 84 degrees. So now we can conclude that lines or segments HI and segments TN are parallel, since the measure of HIL and the measure of TNI are the same, therefore making them corresponding angles. If you try to prove that segment WI is parallel to AN, what you're going to notice is that the angle measure of measure WIL is 61 degrees, and that the angle measure of ANI is 62. Because these measures are not the same, even though they may be corresponding angles, they are not congruent. Therefore, we cannot conclude that segment WI is parallel to AN. In the next example, we want to find the value of x and y that will make segment AC parallel to segment DF and segment AE parallel to BF. We are first going to focus on segment AC, which is right here, and segment DF, which is right here. Now what I'm going to do is I'm going to look at where my x values are. and I'm going to go ahead and mark my transversal as segment BF. So what I notice is if I look at this angle here and this angle here, these are alternate interior angles. And in order for those lines to be parallel, those angles must be congruent. So I'm going to take the first expression of 3x plus 20 and set that equal to the second expression of x plus 50. Now I need to find the x value that is going to make both of those angle measures the same measure once I substitute it back in. So when we solve our equation, we're going to go ahead and subtract x from both sides. We're going to have 2x plus 20 equals 50. And then if we subtract 20 from both sides, we have 2x equals 30. So now when we divide both sides by 2, we get an x value of 15. So now if I was to go back and substitute this back in, I would see that 3 times 15, so 3 times 15 plus 20, so 3 times 15 is 45, and 45 plus 20 gives me an angle measure of 65 degrees. And then if I substitute in 15 here, I also can see that 15 plus 15 plus 50, let me erase that and make that a little clearer for you. So if we have 15 plus 50, we can also see that that will give us an angle measure of 65 degrees, and now we can prove that those two segments are parallel. The next thing we want to prove is that segment AE is parallel to BF. So I'm going to go ahead and mark my line AE, and I'm going to mark my line BF, and then I'm going to mark this transversal right here. So what I can see is that these two angles here, the 2y minus 5 and the x plus 50 are same side interior, so they must equal 180 degrees. So remember from the previous example, we know that this angle is 65 degrees. So now if I take my expression 2y minus 5 and add that to the second angle, which is 65 degrees, I know that they are same side interior angles and they must equal 180 degrees. So now if I start solving my equation, so negative 5 plus 65 leaves me with 2y plus 60 is equal to 180. And when I subtract 60 from both sides, I'm going to be left with 2y is equal to 120. And now when I divide by 2, I can see that the y value that would make both of those angles same side interior angles are supplementary would have to be 60 degrees. So now if I wanted to check this, I could actually substitute in 60 for y. So 2 times 60 minus 5 would give me 120 minus 5, or 115 degrees. So if I take 115 degrees and add that to this angle of 65, I now know that together they will equal 180 degrees, which makes them same side interior angles are equal to 180 degrees, and therefore I can conclude that segment AE is parallel to segment BF. I quickly want to discuss 3 more theorems relating to parallel lines. The next theorem we're going to discuss is theorem 2-8, and this states through a point outside a line, there is exactly one parallel line to that given line. So I think you would agree that there are many lines that can be drawn through point P, but there is only one line that will be not only through P, but parallel. So if we draw our line, we can see that there's exactly one line that will be parallel to line K and also go through point P. Theorem 2-9 states through a point outside a line, there is exactly one perpendicular to the given line. So same type of problem. We can agree that there are many lines that can go through point P, but there is exactly one line that can go through point P and also be perpendicular to line K, which means it would form a 90-degree angle. The last theorem we're going to discuss today is theorem 2-10, which states 2 lines parallel to a third line are parallel to each other. So if we know that line K is parallel to line N, and line N is parallel to line M, I can use my transitive property to say that K is also parallel to M. So again, if K is parallel to L, and L is parallel to M, based on the transitive property, I can conclude that K must also be parallel to M. So when you come into class tomorrow, we are going to practice proving lines parallel. These are the 5 ways that you may prove lines parallel. 1. You may show that a pair of corresponding angles are congruent based on postulate 11. 2. You may show that a pair of alternate interior angles are congruent based on theorem 2-5. 3. You may show that a pair of same-side interior angles are supplementary based on theorem 2-6. 4. You may prove that in a plane, you can show that both lines are perpendicular to a third line, and that is theorem 2-9. And lastly, your 5th way to prove lines parallel is to show that both lines are parallel to a third line, and that is based on theorem 2-10.